Hello viewers, welcome once again. Today we are going to treat compound statement form, still under logic. Then, what is compound statement form? This is a way we can generate statement form from the set of compound statements. This is a generation of a statement from the set of compound statements. Compound statements like conjunctive statement, disjunctive statement, conditional statement, and biconditional statement. These statements are being known by their syntax and the semantics. We say that this is a generation of a statement from the set of compound statements like conjunctive statement, disjunctive statement, conditional statement, and biconditional statement. So these are the set of compound statements from which we can generate statement form. Now, we further say that these statements are being known by their syntax and the semantics. So these statements, we can identify them through their syntax and their semantics. What is the syntax? Syntax is the structure of a statement form. How statement is being structured. That's what we mean by syntax. Then semantics is a meaning we assign to the statement, is what we mean by semantics. Then let us discuss each of them one after the other. We then define it. Let's define it, each of them. You say, let P, Q be statements, and connective or connective implies connective if and only if connective be connectives and I an interpretation. That is to say that we have P as our simple statement and Q as our simple statement. This P and Q denote our simple statement. Then we have or connective, and connective or connective imply connective if and only if connectives. Let them say they are being our connectives, and the I is an interpretation. What we mean by here is that an assignment of truth value to simple statements and the compound statements. Then we go and discuss conjunctive statements. Conjunctive statement. We have our simple statement denotes by P and Q and our connectives. Now let us use and connective to combine these two statements as a compound statement. That means we are going to have P and Q. Now we have used this connective, core and connective, to form a statement by combining these two simple statements P and Q as a single statement form called conjunctive statement. Now I have formed what? Conjunctive statement. This is what we call the syntax of conjunctive statement. We are going to identify conjunctive statement by this kind of form of the statement form. So we say that is a syntax of conjunctive statement. Then this P in this conjunctive statement, P and Q, they are called conjuncts. These are simple statements, P and Q, they are called conjuncts. P and Q are called conjuncts. So in this statement, P and Q called conjunctive statement. P and Q, they are called conjunctions. Let us go to the semantics. We say that let I be an interpretation, that means an assignment of truth value to our simple statement or to our truth valuation. You say that let's wipe off this place. We then have to say I of P Q is equal to T if I of P equal to I of Q equal to T. That means if the assignment of truth value, I assign 1 to this P and Q, this our conjunctive statement. If it assign it to 1, that means it's being evaluated to T. When I evaluate P and Q in this compound statement called conjunctive statement, if it is being evaluated to 1, that means that I assign P to T and also assign Q to T. So if I assign P to T and assign Q to T, that means we are going to have our truth valuation of this statement to be T, which is our truth, which is called truth. Otherwise, you say 0. We say is 0 otherwise. That means if I assign P to any other truth value other than signing P to T, signing Q to T. Another way you can sign it, we evaluate the conjunctive statement to F. Sorry, this is to F, which is false. It will be evaluated as what? As false. That is the syntax of. So you say that this is the semantics of conjunctive statements. We say that truth table is used to show all the possible combinations of truth values of the simple statements. and the valuation of the statement. Now, having known this is our semantic, how we can interpret the statement P and Q. Now, we can use truth table to show all the possible how we can assign truth and falsity to each combination of simple statements, so that we can evaluate it, we can evaluate them and it will have the truth valuation of the statement. That is the use of the truth table, which I am going to use now. You say example of truth table for conjunctive statements. We draw a truth table Now, in our statement, this is our conjunctive statement, where we have P and Q. We have two simple statements. We know that our formula to determine rows in truth table is 2 power n, where n denotes the number of simple statements involved in the statement. Now, we have two simple statements involved in this our conjunctive statement. That means P and Q, that is 2. That means 2 power 2. We are going to replace that n, 2 power n, replace n with 2. That means 2 power 2 is equal to 4. So we have to have 4 rows. That means we have 4 possible ways we can combine the truth value of simple statements involved in the conjunctive statement. We draw it. This is our truth table. We draw columns 1, 2. We draw rows for each statement. Then you have first row, second row, third and fourth row. We have our statement P and we have Q. Then we have our conjunctive statement P and Q. is our statement. You have known that we have 4 rows. Now, the first statement, we are going to divide the rows into 2 so that we can assign the first 2 will be true or true. Then the last row will be assigned to false true, the F symbol throughout. Then we assign T symbol to the first rows and assign the last rows with the F symbols. That means we divide it into 2 so that they will be equal. There will be 2 and 2 truth values and 2 false truth value. See what we mean here? T here, T here, F here, F here. So in order to get all the whole possible combination, then in this Q, we are going to divide this one into 2. This T, you have 2 T's here together. We are going to divide it into 2 so that we are going to sign first one 2, then second one will be false. Here, what we mean here is that here will be truth, because 2 divide 2 will give us 1. That means I'm going to have T here and then F here, then T here, F here. We have now gotten all the whole possible combinations of truth value of simple statement P and the Q. Let us go over to the conjunctive statement, this P and the Q. Now, we know that in our semantics, we say that when I assign T to P and when I assign P to T and assign Q to T, we're going to have truth as our valuation. That is the only way we can have truth in our valuation. Otherwise, it will be F, false. So T and T is T. Here, F, T and F, that means it's otherwise. It's not T and T, it is F. Here, have F and T, that means it is otherwise. It is F. F and F is otherwise. It's not T and T, so it's F. So we have shown all the whole possible truth valuation of the conjunctive statement P and the Q, and all the whole possible combination of truth value of the simple statement. So here we have T, F, F, F as our truth valuations. Then when I assign P to T and assigns Q to T, we have T. When it assigns P to T, assigns Q to F, we have F. When it assigns P to F and assigns Q to T, we have F. When it assigns P to F and Q to F, we have F. So this is all about the truth table of P and the Q. Let's go to disjunctive statement. Disjunctive statement. We know that we have our simple statements P and Q and our connectives, and or implies if and only if connectives. Now we are going to make use of or connectives to combine the two statements P and Q as a statement form or a compound statement called disjunctive statement. That means we have P or Q as our disjunctive statement. We have used or to combine the two simple statements as a one statement called disjunctive statement. So it is being now known by the syntax that P or Q is disjunctive statement. We say is a syntax of disjunctive statement. Then P and Q in this disjunctive statement, they are called disjuncts. They are called disjuncts. P and Q are called disjuncts. So this is the structure of our disjunctive statement by using this or combination to combine the two simple statements to form the disjunctive statement P, or read as P or Q. Let's go to semantics. Then we know that I is an interpretation that assigns truth value to P and Q and assigns truth valuation to the whole statement P or Q. That means evaluates the P and Q and assign truth valuation to P or Q. You say I of P Q is equal to 0. So it's equal to F. Is equal to F if I of P equal to I of Q equal to F. We say T otherwise. That means whenever I assigns P, that means the truth assignment to P is F and truth assignment to Q is F. That means they are equal. They have the same truth value of F. That means I of P is F and also I of Q is F. When it's being evaluated, it will be F. Otherwise, it is truth. So that is what we mean by this is the semantics of disjunctive statement. Then let us use truth table to show all the possible combinations of truth value of the simple statement involved in our disjunctive statement and also the each truth valuation of each combination of the truth value of the simple statements. Let's use two tables as an example. Example of truth table for disjunctive statements. Example of truth table for disjunctive statement. We draw our, you write the heading truth table. We then draw it. This is our statement column. We have two statements in the disjunctive statements, P and Q, and we know that our formula for determining the rows in truth table is 2 power n, where n denotes the number of the simple statements involved in the statement. Here we have two simple statements involved in the statement. That means we are going to replace n by 2. I'm going to have 2 power 2, which is equal to 4. That means I'm going to have 4 rows in the table. We draw first column, second column. We have first row, second row, third and fourth row. Then we have our first simple statement P and second one Q. We then have our disjunctive statement P or Q. Then we are going to, since we have 4 rows, we are going to share the truth tables half. That means we are going to assign truth to first 2 rows. We are going to assign truth. We are going to assign truth OPS to the first 2 rows. 2 rows are going to contain the 2 rows first will contain truth. Then last one will contain false. The last rows, that means the third and fourth row, will contain false. And we have what I mean here, you have truth, false, false. Then here we are going to divide this one by 2 to know how we're going to portion the truth value in Q. Divide it, we have 1. That means we're going to start with T. Then another one will follow is F. Another one will follow is T. Another one is F. Having known this one, we said that in our interpretation, the assignment of truth value and valuation, we said that the truth valuation of P or Q is 0 if I assigns P to 1 and assigns Q to if I assigns P to F and assigns Q to F, that means the valuation will be F. Otherwise, it is truth. Let me, it is F, it is T. That means what we here that T or T will give us, let's start from here. Here you have F or F. That means I assigns P to F, assigns Q to F, and that is the only condition we can have false in that statement. So if assigns P to F and I assigns Q to F, we're going to have F. Otherwise, we say it is truth. That means F or T, it is T. Then T or F, it is T. It is otherwise. T and T is also otherwise is also T. So this is the truth valuation and the truth value computation of each simple statement. So that whenever I assigns P to T and assigns Q to T, we are going to have truth valuation as T. When it is T and F, it is T. When it is F and T, it is T. When it is F and F, that's the only condition, it is F. So that's our truth valuation is T, 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 F in their possible combinations. So this is all about the truth table of disjunctive statement. Thank you.